Hello everyone. Hope you're all doing well. Hope you're all happy. The problem we have at hand today is getMazePaths, and let's figure out what the question is. The question says we are given a number n and we are given a number m representing the number of rows and columns of a maze. We are standing at the top left corner of the maze and we are required to reach the bottom right corner of the maze with only two moves allowed. We can take a horizontal step or we can take a vertical step. We have to complete the body of this function without changing its signature to get the list of all paths that can be used to move from top left to the bottom right. So basically, if they give an input of this, that is the size of the maze, we have to return a list containing all the paths we should take. So let's explore the question once more. Let's say n equal to 3, m equal to 3. So we take the maze to be a matrix. It's a 3 by 3 matrix. We are here and we are supposed to reach here from the top left to the bottom right. What we have to do is we have to return a list containing all possible paths from this point till this point. That is, also one more thing we have to keep in mind is when taking a horizontal step, this is called H. When taking a vertical step, this is called V. If we take a vertical step, it is called V. If we again take a vertical step, it is called V. If we take a horizontal step, it is called H. Okay. So what we have to return is we have to return all the possible paths that we can take from top left to the bottom right. What are the possible paths we can take? We can take 2 horizontal steps, 2 vertical steps, right? So 2 horizontal, 2 vertical, or we can take 2 vertical, 2 horizontal. So we do that by 2 vertical, 2 horizontal, or we can take a horizontal step, a vertical step, a horizontal step, and a vertical step. So that is denoted by horizontal, vertical, horizontal, vertical. We can also take a vertical step, horizontal step, vertical step, horizontal step. We can take vertical, horizontal, vertical, horizontal. Also, we can take a vertical, 2 horizontal, and a vertical. A vertical, 2 horizontal, and a vertical. Or we can take 1 horizontal, 2 vertical, and a horizontal. 1 horizontal, 2 vertical, and a horizontal. So there are 6 possible paths for this n equal to 3 and m equal to 3, right? We have to return this list. Also, we are given hints that we are solving this with recursion. So let's see how to solve this problem. Also, before we are solving the problem together, I request you all to go and try to solve the problem by yourself. Programming is a skill and practice is the best teacher. So it's better that you solve the problem yourself and come here to compare your solution with ours. Okay. Now we are solving the problem. How are we solving the problem? We are solving the problem using recursion. For any recursion, there should be faith, right? Again, we are taking the same maze. N equal to 3, m equal to 3. We're here, we're required to reach here. What is our faith? We have a faith that we'll take one step. Okay, either it is horizontal or it is vertical, and we'll stand here and we'll see, and we have a faith that at this point I'll get all the paths that is required to reach this point. Okay, in this point I'll get a list of all paths that can be used to reach here, and what I'll do is I'll add whatever step I took. Okay, I took a horizontal step, so I'll add with that path list, I'll add H to my answer. From here, I have a faith that I'll get all possible paths from here to here at here. What my job is to add whatever step I took. Let's say if we are at this position, okay, what do we expect? We expect a list containing all possible paths from here to here. What are those paths? Let's figure out. We'll take a horizontal step and 2 vertical steps. Okay. that is one horizontal, two vertical. You can also take two vertical and one horizontal, two vertical and one horizontal. We can also two vertical and one horizontal. We can also take one vertical step and one horizontal step and one vertical step, right? You can also take one vertical step, one horizontal step, and one vertical step. What our job is to add edge to all these answers. Okay, the same way from here, we expect a list containing horizontal, horizontal, vertical, vertical, horizontal, horizontal, or horizontal, vertical, and horizontal. So from here we expect this list: horizontal, horizontal, vertical, horizontal, vertical, horizontal, vertical, horizontal, horizontal. We expect this list. We have a faith that this point will give me this list. What my job is to add whatever step I took, and we'll form this as a single list and we'll return the answer. This is how we're going to solve the problem. Now let's see how to solve this problem. Okay, we say if we have to take a horizontal step, right, and we expect we to get in return a list. So horizontal answer is equal to getMazePath from the current position. Here we are taking a horizontal step. So what happens is we again have the same 3 by 3 maze. When we take a horizontal step, that is when we take a horizontal step, the column number increases by 1, right? So this is column number 0, 1, 2, 0, 1, 2. When we take one horizontal step, the column number increases by 1. So what we have to do is we have to say from here we say source row remains the same, source column increases by 1, destination row and destination column remain the same. Similarly, our vertical answer will be we take one vertical step and we say you get me all paths from that point. We have a faith that this will work. The same way, when we take a vertical step, our row number increases by 1. SC, DR and DC remains the same. Now, also we have to take one thing into consideration, that this program, when we call it recursively, we take a horizontal step and we call the program again. So it takes a horizontal step again. Now we call the program again, it takes a horizontal step. We should not go out of the maze by any means, right? So what we have to do is we have to restrict ourselves within this range and within this range. So we should not cross these boundaries. How do we say that to a program? We say whatever step I take, if source column plus 1 is less than or equal to destination column, only then you take this step. Similarly, for this we say if source row plus 1 is less than or equal to destination row, only if this condition is met we are taking steps. Okay, we took 2 steps and we have a faith that this will give us the horizontal answer. Now what is our job is to add whatever step we took to this answer, right? So we'll make an answer, we'll make a list, my answer is equal to an empty list. What we do is for every string, or we can say for every element in horizontal answer, for every element in horizontal answer, what we say is we say my answer dot append whatever step I took plus the element. Also we have to add this horizontal step before this element, because first we are taking the step and then we are calling the recursive function, right? So whatever step we took comes first. Similarly, we say for every element in vertical answer, what we do is we add it to my answer dot append a vertical answer plus this element. Okay, this is basically the program. What we have to do is we have to return my answer. It's nearly done. Now what we have to do is we have to think of the base case. What will be the base case? The base case is obviously when we reach this point, right? When the recursive call happens, what the base case is? The base case is that n equal to 0 and m equal to 0. That is, we have one row and one column. That is basically we have one cell. We are here and we are supposed to reach here itself. And we are supposed to return a list containing strings of whatever step we have to take. So what we have to do is we don't have to do anything to reach from here to here. So we'll return an empty string. Okay. What it is, if source column is equal to destination column and source row is equal to destination row. If this is the case, we make a base answer. Base answer is equal to a list containing an empty string and we return the base answer. Okay, basically that's the program. Let's try to run this. Yeah, we get the correct answer. Let's try. Alright. Our input is n equal to 3, m equal to 3. So we pass destination row is equal to 2, destination column is equal to 2. Also guys, one thing we have to keep in mind is in Python, the matrix indexing starts from 0. We're using 0, 0 as the starting position and n minus 1, m minus 1 as the ending position. We can also use 1 based indexing. We just have to pass 1 and 1 here because we just need the path, right? It's a string. We don't have anything to do with the indexes of the matrices, so we can also pass this. It gives the same answer. We'll use this because this is less code complexity, right? We don't have to remember other things. So we are at 1 1 and we have to reach 3 3. Okay, we are at 1 1. Now what happens is we are passing 1 1 and 3 3 here. Now we're checking if source column and destination column was same. No, now it comes here. It makes a recursive call adding 1 to the column number. Also similarly we make a recursive call in the vertical direction also. So this makes two calls, one in the horizontal direction and one in the vertical direction. In the horizontal direction it goes to 1 comma 2. The same here, we'll make a horizontal call and a vertical call. Here by reaching here we reach 1 comma 3. Now we cannot make horizontal calls anymore because 3 plus 1 is 4. We cannot cross this, right? So we can only make vertical calls. In the vertical call we reach 2 comma 3 and after this we reach 3 comma 3. This is the base case. We'll see what happens. We'll finish the tree first. After 1 comma 2 making a vertical call we reach to 2 comma 2. This again makes two calls in the horizontal and vertical directions. In the horizontal direction it reaches 2 comma 3. In the vertical direction it reaches 3 comma 2. This cannot make any more horizontal calls, so it makes a vertical call, it reaches 3 3. This cannot make a horizontal call, so it makes a it cannot make a vertical call, so it makes a horizontal call and it reaches 3 3. In here it makes a vertical call, right? I misspelled it. It makes a vertical call and it reaches 2 1. From again here we make a horizontal and vertical call. From horizontal call we reach 2 comma 2 and with vertical call we reach 3 comma 1. From here we again make two calls, horizontal and vertical. With a horizontal call we reach 2 comma 3 and with a vertical call we reach 3 comma 2. We can only make a vertical call, so we reach 3 3 and with a horizontal call we reach 3 3. Here we can only make horizontal calls. We make 3 2 and with a horizontal call we reach 3 3. These are all base conditions, right? What happens here is we'll make a list containing an empty string, and when this returns here, this b is added to this string. Now this returns here, another b is added. This returns here, an h is added. It returns here, another h is added. So here we have a big list. In here we add, when returning we add v, and before that we add another v. When coming here we add a h, and from when coming here we add another h. So this is one solution from one branch of the tree. We also get the same solution in this way, right? So we get HV, 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 HV. Also we get HV, VH, HV, VH. In this side we get V coming from here, VH, HV, VH, HV. Also here V, H, VH, VH, VH. And coming here we get VVHH, VVHH. And this returned to the function which called the main function, right? In Python, it is returned to the point where the function call is made. So this answer is returned here, and this function prints the solution, and that's how we reach the solution. And thank you everyone for watching. If you have any doubts, you can leave them in the comments. We'll try to answer them. If you like this video, please hit the like button, subscribe to Pepcoding, and I'll see you in the next video. Thank you.